Today, we're diving into a question that sounds like it's straight out of science fiction, but it's a very real and very old human dream. Can we actually control the weather?
I mean, come on, who hasn't wished for this? You've got a barbecue planned and boom, storm clouds roll in. Or maybe you're watching your garden just bake in a drought. In those moments, who wouldn't want the power to just, tweak the forecast a little?
And this isn't some new idea. For centuries, we've tried everything: rain dances, rituals, and, as we're about to see, some pretty wild inventions. But today, the story has moved out of the world of magic and squarely into the world of hard science. So, let's see how it's actually done.
So when scientists today try to modify the weather, it's not about wishful thinking. They use very specific, very deliberate strategies that pretty much all fall into three basic categories. Think of it like a toolkit with three main approaches. First, you can use pure brute force, like applying a ton of heat. Second, you can change the ground itself, modify the land or water to change how it interacts with the air. Or third, and this is where most of the really cool modern science is happening, you can try to kickstart or enhance atmospheric processes that are already about to happen. We're going to be focusing mostly on that third one.
All right, let's kick things off with the big one, the one everyone's heard of, cloud seeding. This is the ultimate quest to make rain on demand, and it's been the holy grail of weather modification for decades.
The whole field really exploded back in 1946 thanks to a guy named Vincent Schaefer. He discovered that if you drop dry ice into a cloud full of supercooled water droplets, that's water that's below freezing but somehow is still liquid, which is wild, it would instantly cause ice crystals to form and grow, and bam, you get precipitation. That was the breakthrough that started this whole thing.
So you've got these two main ingredients, and the difference between them is actually pretty clever. Dry ice is basically the brute force method. It just makes things super, super cold. But silver iodide? It's much more subtle. Its crystal structure looks so much like an ice crystal that it basically tricks the supercooled water into freezing around it. It's like a tiny, irresistible seed that the water just has to grab onto. And because of that, it's way more efficient and a lot easier to use.
Sometimes the biggest discoveries are complete accidents, and that's exactly what happened here. Researchers noticed that it seemed to rain a lot more around this one paper mill. Well, it turns out the mill was pumping out these tiny little salt crystals, and these crystals are hygroscopic, which is just a fancy way of saying they are total water magnets. They literally pull moisture out of the air, forming droplets, and suddenly, scientists had a brand new way to try and seed clouds that weren't even cold.
Okay, so the big question is, does any of this actually work? Well, it's not some magic button you push to make it rain, but the evidence is definitely starting to pile up. Really careful experiments in places like Western Texas are showing a consistent 10% bump in rainfall from clouds they've seeded. Now, 10% might not sound like a huge number, but if you're a farmer in a drought, believe me, that 10% is everything. Okay, so it turns out the very same science that can make it rain can also be used for something incredibly practical: getting rid of dangerous fog, especially at places like airports. And just like with making rain, it all comes down to temperature. You've got two kinds of fog. If the fog is super cooled, meaning it's made of those liquid water droplets that are below freezing, then yeah, you can use the same seeding tricks we just talked about. But if it's a warm fog, you're out of luck with seeding, which is a pain because that's the kind you see most often. Now, when it comes to that super cooled fog, yeah, we've pretty much got that figured out. It's a solved problem. The US Air Force has been doing this for years. They fly a plane, drop some crushed dry ice, the water droplets turn into ice crystals and fall to the ground, and a clear path just opens right up. It's a proven, reliable technology. But that pesky warm fog? Well, for that, you have to go back to that first strategy we talked about, just pure brute force energy. And this is a wild example. At an airport in Paris, they literally have jet engines buried alongside the runway just to blast hot air at the fog and make it evaporate. I mean, talk about overkill. It works, but wow, is it expensive. All right, we've talked about the practical. Now let's get into the trauma. Because for centuries, humanity has been in an all-out war against hailstorms, which are, some of the most destructive things nature can throw at us. And it's not hard to see why people are so obsessed. We're talking about $500 million in damage every single year in the US alone. That's just the average. A single big hailstorm can do more damage than a hurricane. The motivation to stop it is massive.
And this, my friends, is where the story takes a turn for the truly bizarre. Back in the 1880s, the top scientific theory for how hail formed was completely wrong. They thought hailstones were these delicate things that grew in really calm, peaceful clouds. So the solution seemed obvious, right? You just got to shake things up a bit.
And this was their chaos machine, a massive 9-ton cannon that basically shot a giant smoke ring and a super loud whistle up into the sky. It sounds absolutely nuts, I know, but a test seemed to work, and suddenly all of Europe had cannon fever. Thousands of these things were built, all based on totally wrong science.
So flash forward to today. We've swapped the cannons for cloud seeding, trying to make a bunch of tiny hailstones instead of a few giant ones. So what's the verdict? Well, after tons of research, there's just no real proof it works. The war on hail goes on, but honestly, we're not winning.
All right, let's bring it back down from these massive storms to something smaller, but no less important, especially if you're a farmer fighting off a frost that can kill your entire crop in one night.
See, the key here is knowing that not all frost is created equal. If a giant Arctic cold front is rolling in, there's not much you can do. But you can fight something called a radiation frost. This is what happens on those really clear, calm nights when the ground just radiates all its heat away into space, and the air right at the surface gets dangerously cold.
And the ways farmers fight it are pretty amazing. Just simple physics, really. Take sprinklers. It sounds totally backwards, right? Why would you spray water on plants when it's about to freeze? Well, here's the cool part. As that water freezes on the plant, it actually releases a tiny bit of heat, what's called latent heat. And that little burst of energy is just enough to keep the plant itself right at 0 degrees Celsius, saving it from damage. Pretty clever. Okay, so we've covered a lot. Making rain, clearing fog, fighting hail, stopping frost. Let's step back and look at the big picture. What have we actually figured out, and what's still just a dream?
So here's the final report card. What have we totally nailed? Dispersing that supercooled fog, that's a check. What's looking pretty promising? Cloud seeding for more rain and snowpack under the right conditions? Yeah, the results are looking good there. And what's still a total bust? Hail suppression? Sorry, still no proof. And that idea of seeding warm clouds with salt? Still very much in the early experimental stages.
So we have clearly gone from ancient magic to modern science. But as our climate gets more and more unpredictable, the desire to use these tools is only going to get stronger. And that leaves us with a huge question. It's not just can we do this anymore, it's should we?